Hi everyone, my name is Thomas Kim. Today is July 4th, 2020, or 4th of July. This is my 41st episode about the programming language C++ 20 standard. In this episode, I will discuss pack expansion in Lambda Init-Capture. This is new feature introduced to C++ 20 standard. In ISO C++ homepage, if you double-click this link, ISO-CPP.org, compiler conformance status, C++ 20 core language features. This is GCC compiler, Clang compiler, Microsoft Visual C++ compiler. If you scroll down, you can find parameter pack expansion in Lambda Init-Capture, GCC, Clang, Microsoft C++ compiler supports pack expansion in Lambda Init-Capture. For more information, please double-click this link. If you read this documentation, you can have more information about pack expansion in Lambda Init-Capture. This feature was introduced to C++ 20 standard. You can also refer to this documentation. Please double-click it. In C++reference.com, Lambda expression, this is the capture, Lambda capture. If you scroll down, you can find Lambda capture section. In this section, we will cover this part. So, in this syntax, by copy capture with the initializer, that is a pack expansion. With this syntax, by reference capture with an initializer, that is a pack expansion. Also, I will cover how to use concept paraname. Then I will cover how to interrogate and or retrieve types of parameters in a pack. Then I will cover how to pass function template as function call parameter. Finally, I will explain how to resolve type mismatch or type conflict in template metaprogramming. I believe this session is quite advanced for most audience. By the time you watch this video, you can double-click this link and download complete source code. Without further ado, let's get started. Start your Visual Studio Code. Open your working folder. Select empty space. Click this button. 041 Lambda Init-Capture. Hit enter. Click this button, init-cap.cpp. Hit enter. Ctrl V. Include talk play fun output HPP. Talk play fun stream auto and there talk play fun and there. Void test para name int main. I will call this function name in the function main. Here template type name concept para name true. We defined a concept called para name. Struct output. I defined a struct friend output value reference operator output out para name auto. This is value reference parameter stream para return out. This is destructor output stream and there. We defined a struct. This syntax is new to C++20 standard. I will explain how to use this syntax once again. Here, void printout parameters. Para name oro. This is R-value reference. Parameter pack args. We create an instance of output out. Now we use fold expression out. We call operator, this operator, then 3 dots or ellipses, binary operator once again, this operator, then args, semicolon. Now we call this function like this. Here, inta 5 double b 3.14 a b 3 3.4f. We are calling this function. This function calls fold expression over arguments args using fold expression. Now start command prompt. dir cd 041 lambda init-capture g++ std c++20 init-cap.cpp ltbb o g.exe. Hit enter. This program built successfully. CLS G. So A is 5, B 3.14, 3.4 is displayed by calling this function. In this function called parameter list, paraname is defined here. Concept. We are using keyword oro. This is forwarding reference, and args is parameter pack. This syntax was introduced to C++20 standard, and it turns out to be very powerful for modern C++ programming. Before C++20 standard, we could have written like this too. Here, type. Now we build again. We build again. G. First off, this syntax is much cleaner than this syntax. Also, this syntax is much more powerful than this syntax. For example, oro, sum, para, name, oro, args, return, args, plus I use fold expression once again. Now here, void test fold expression with concept. Now I call this function like this. oro rlt sum 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stream 1 plus 10 equals rlt and there. Now we call this function, copy, paste it here, disable it. We build again. CLSG. So we call the sum this function. Now we change the parameter to 0.8. We build again. CLSG. This function works correctly. Now I scroll up here, template, type name, type, concept, integer, talk, play, fun, types, is type, in list, std, remove, cv, reference t, type, int, long. In this type list, we allow only int and long. Now I copy integer, paste it here. Now this function does not work. We build again. The error message comes from 55 at this line because we allowed only integer and long. Now I will rename this concept to real. Also I will add float and double. So real comes here. We build again CLSG. Now I will introduce type list. Here using allowed types, talk, play, fun, types, type list T. I will copy this part, cut, paste it here. Now here, allowed types. We build again CLSG. For more information about type list T, right click, go to definition. It is defined like this. In the header file, talk, play, fun, types.hpp. Now I will close this file. We have to understand what are the types of ARGS, function call arguments. I scroll up. This function has a minor bug. I will explain why. Now scroll down. Void test minor defects. Output out INTA 5 stream A is A and L. I copy this function, copy, paste it here. I disable it, stream, literal 5. Sorry, it should be out. I will disable it for the time being. Also out. This line works correctly. Let's test it. It builds successfully. But if I enable it here, 5, we build again, it does not work. The error comes from 5 here. If we scroll up, this operator function does not work. We need to know the type of parameter. This is L value reference. If we scroll down, this 5 is R value. So to fix this issue, we have to fix this code to forwarding reference. Now we build again. It should work. CLS-G. Now I scroll down. In this function, we used forwarding reference. I will disable it. Ctrl K, Ctrl C, and re-enable it. In this syntax, function call parameter list, having solid understanding of the types of function call arguments is very important. Also, in this function, having concrete understanding of the types of function call arguments is crucial for successful modern C++ programming. Having solid understanding of the types of the function call arguments is crucial for successful modern C++ programming. How can we figure out the types of ARGS? How can we figure out the types of ARGS? How? We can use type list. I scroll down right before function main, auto pack to types, paraname, auto ARGS. This is return type, talk, play, fun, types, type, list T, DECL type, ARGS, expansion, angle bracket, semicolon, hit enter. Define, talk, play, fun, pack, two types, ARGS, DECL type, pack, two types. We call this function ARGS. Here, auto summation, real auto forwarding reference, ARGS, return ARGS. We use fold expression using ARGS types T. We call this macro ARGS stream. Types of ARGS. ARGS types T. This is an instance. And there. Now scroll down. Void test pack2 types. I will copy this function name. Copy. Paste. I will disable it. Here. INTI 5 constant C 3 int double D 3.14. Now we are calling this function I C D 4.5F. This is float. 4 LL. This is long. Now we rebuild CLS-G. So the type of I is integer L value reference. The type of C is constant integer L value reference. The type of D is double reference. This is float reference, long reference. Here we have to fix std forward copy decl type arg. We have to fix our code like this. Now let's rebuild G. So float is R-value reference. For the type of for is R-value reference. This talk play fun pack to type macro is very handy when we want to figure out the types of function call parameters or arguments like this. For example, we want to know the type of the first argument like this using first t talk play fun types first type t. We provide args types t here using last t. I will copy this, paste. It should be last type t. Using second t, I will copy this once again, paste. It now should be select nth type t. I copy and paste here. Stream first type talk play fun get type name first t and there copy paste last type last t copy paste second type second t. Now we build again. We have to provide 1 because the index start with 0. We build again cls_j. So in this function call, the first type of this argument is integer reference or integer L value. The second type is constant integer L value reference. For LL, the last type is long integer R value reference. So long integer R value reference, the last type. This function works correctly. I originally planned to discuss pack expansion in Lambda Init-Capture, but this session became too long, so I will discuss this feature in my next episode. Also, in my next episode, I will discuss how to pass function template as function call parameter. Also, I will discuss how to resolve type mismatch and what type conflict in template metaprogramming. Please subscribe to my YouTube channel. Thank you for watching.